Now we proceed. On a previous video, we discussed a few concepts related to Cosine rule. So we spoke about this. Let me take a pen here. We spoke about these formulas here, and we agreed that whenever we have a squared here, we must have cos A. Whenever we have B, we must have cos B this side. Whenever we have C, we must have cos C this side. And we must always consider the square of the adjacent sides. So this is what we spoke about on the previous video. Now we want to prove Cosine rule. Let's see. We have two ways of proving Cosine rule. So I will start with number one, where we consider A as acute angle, then we prove the Cosine rule. Then we consider A as obtuse angle, then we prove the Cosine rule. Let me grab a pen here. Let me grab a pen. There we go. So when we made this type of equation in exam, and they say to you, prove the Cosine rule. So firstly, you should consider what is given, which is your triangle. So step number one, you have to construct the height. Remember, in the exam, this height is not going to be given to you. You have to construct it. So you construct the height. After constructing the height, you can give the name of this distance. In this case, I will give it the name B. B is the distance from A up to C. Then from there, I will consider this triangle here. I specify that in triangle BDC, I'm talking about this triangle here, which is B. The top one is B, FD, FC. So I consider this smaller than a triangle here. Then I'm going to use Pythagoras theorem because I'm given the right angle triangle. Then I'm writing down my Pythagoras theorem. Remember that if this is angle A, here I'm having the smaller a. Then I say E squared is equals to BD squared. This is BD squared. This height here is BD squared plus CD squared. And I can state my reason there to say I'm using Pythagoras theorem. So look at this statement carefully here. You can see that inside the bracket, I have this term here, which is B minus AD. So allow me to clarify this part. B minus AD. Where is this term coming from? Look what is happening. The distance from A up to C is given by B, but this distance from A up to D is called the distance AD. So whenever I'm looking for this distance, I will consider the bigger distance minus the smaller distance. That is why I will say B minus AD, I'm going to get DC. I can repeat it. CD, this distance here, is given by the bigger distance, subtract the smaller distance. Then we get distance DC. That is why here we substitute DC by B minus AD. I'm sure this part is clear. Feel free to repeat this video and listen how we obtained this term. It's very important. When we proceed, here we simplify because we have B minus AD all squared. So what do? We say B squared. Then we say B multiplied by AD multiplied by 2. Then we have 2 BAD plus this positive comes simply because of we said negative squared, we get positive AD squared, then we have AD squared here. In fact, this thing you can write it as B minus AD into B minus AD. Then you simplify it, then this is what we're going to get. So far, I have a perception that you are able to simplify this type of expression to move from this step to this step. But check what is happening. C squared, when I'm referring to C squared, I'm talking about this side here. This side is C. And now when we consider C squared, we are going to say C squared is given by the square of the sum of the adjacent side. BD, we have BD plus AD squared. Remember, this is our C. We are now talking about this triangle here, which is called triangle ADB. I can try to highlight the triangle ADB. We have C here. In this triangle, I'm going to apply Pythagoras theorem. Pythagoras theorem states that the hypotenuse is always the square of the sum of the adjacent sides. Indeed, here we have AD squared. We have plus, we have AD squared. Is our AD squared plus BD squared. This is BD squared. Here we are. So the square, the sum of the square of this adjacent side is equal to C squared. And that is our Pythagoras theorem. So we proceed. Let me grab another pen. Maybe I can use another color instead of that one that we used before. Let's see. And let's grab maybe blue. So this is what we have. I will clarify where this statement comes from. So we have A squared equals to B squared plus C squared minus 2B AD. And we're going to label this equation now. So what I did, where there is B squared and AD squared, I substitute that by C squared. Let me highlight this so that you can see clearly. We see that instead of B squared plus AD squared, we substitute by C squared. That is why we have C squared here. On this statement here, where there is B squared plus AD squared, we write C squared. That is why we have C squared here. Let me clear my drawing, and then let me take the vanishing pen. Good. So this is our equation 1. Then we're going to create our equation 2 by considering the cos of A. In our diagram here, you can see that the cos of A is adjacent. Cos of A is adjacent, and our adjacent side is AD over hypotenuse, which is C. Then here we make AD the subject of the formula, then we cross multiply. That is why here of AD equals to C, the cos of A. So we have 2 equations here. How do we proceed from here is very easy. You substitute where there is AD. You substitute by C, the cos of A. So this part comes here. Let's repeat it. I say where there is AD, you substitute AD by C, the cos of A. This part comes here. So this is what we do here. You substitute equation 2 into equation 1. You can see that when we do that, so we still have everything as it is here. But AD is represented by C, the cos of A. So this is indeed the proof for cosine rule. So similarly, we can do others here. I would like us to go slowly through this problem step by step. So here we were given a triangle ABC, and we are told that A is an acute angle, meaning it's an angle that is less than 90 degrees. So the first step that we did, we considered triangle BDC. So in this triangle, we applied Pythagoras method. We said A squared is equal to BD squared, and this is our BD. This is our BD squared equals to CD squared. So we consider this triangle this side, and we apply Pythagoras theorem. A critical part is here where we have to know what is CD. Can grab a pen and try to emphasize my point. So look at what is happening. Let me take the vanishing pen. So look at what is happening. CD, this distance is given by the bigger distance, which is B, minus AD. That's what we said here. Then from here, we simplified this expression to get this part. And then we now consider Pythagoras theorem, but this time we consider Pythagoras theorem on this triangle, which is here, which is triangle ADB. In triangle ABD, we apply Pythagoras theorem to consider that this side here, it's our smaller c. And smaller c is opposite to 90 degrees, which makes c to be hypotenuse. And Pythagoras theorem says that the side opposite to 90 degrees is always equal to the square of the sum of the adjacent sides. The adjacent sides of C is AD and BD. That is why here we have BD squared plus AD squared, which is equal to C squared. Now look at this here, BD squared and AD squared. These two things combined, they give you C squared. It is on this statement here where we substitute BD squared plus AD squared by C squared, meaning where we see BD squared and AD squared, we replace them by C squared. Remember, we have to take this thing, maybe write it next to this one here before you substitute. So that's why we have C squared, and then we still have our B squared here, our B squared, and our A squared. We still have it here. And then this term here, we still have it, which is minus 2BE. And let's label this equation number 1. When we proceed, we say now in triangle ABD, the cos of this angle here is given by the adjacent side, which is AD, divided by hypotenuse, which is C. Having done that, we make AD subject of the formula. Then we cross multiply, then we have C, the cos of A. We have 2 equations. I mean, when we proceed, it's easy because where there is AD, we just replace AD by C, the cos of A. Then we are done with our proof. Having done that, we have A squared plus the B squared plus C squared minus 2BC, the cos of E. So, ladies and gentlemen, this type of question is an examination type of question. I would really like to advise you to repeat this proof and ensure that you follow all the steps. And again, thank you for watching, and let's meet again on the next session.